Dear students, let's continue with question number 8 of exercise 6.5 today. It's given that in the figure O is a point in the interior of triangle ABC. The figure is given here. You can see O is a point in the interior of triangle ABC. And it's also given that OD is perpendicular to BC, okay, and OE is perpendicular to AC. Also OF is perpendicular to AB. So these all things are given in the question. We have to prove OA square plus OB square plus OC square, okay. We have to prove that OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equals to AF square plus BD square plus CE square, okay. So it's looking lengthy but nothing complicated. We can easily prove it. This is one of the most important question again for 4 marks. So I have taken what's given in the question. I have written here. You can have a look. Then RTP is also taken here, whatever is required to prove. Now how to prove it? So let's proceed with that. So I'll take the triangles. First we'll join point O from A, B and C using Pythagoras theorem. We'll use Pythagoras theorem here, that is hypotenuse square is equals to height square plus base square. Now which triangles I should apply? There are so many triangles. There are so many right angle triangles. There are around 6 right angle triangles in this figure. So we'll apply Pythagoras theorem to these triangles which I have shaded. Now why should we apply Pythagoras theorem to only these 3 triangles? That's a question. We should apply only to these 3 triangles because you can see here in the RTP required to prove, it's given AF, BD and CE only, okay, AF, BD and CE. So that's the reason I have taken the alternate triangles in which AF, BD and CE comes. So according to RTP you should proceed now. So in this triangle AFO, the green colored triangle, which is the hypotenuse, AO is the hypotenuse, okay. So I can apply Pythagoras theorem to this triangle. So I get OA square is equals to AF square plus OF square, AF square plus OF square. In the same way I'll apply Pythagoras theorem to the other triangle, that is OBD triangle. So in this OBD, OB is the hypotenuse, so OB square is equals to OD square plus BD square. Then I'll apply the theorem to triangle OEC. So which is the hypotenuse in OEC? Because this is 90 degree here, OE is perpendicular to AC, OC is the hypotenuse, that is the longest side, okay. So let's apply the Pythagoras theorem to triangle OEC. So what we get here, OC square, okay, we get OC square is equals to OE square plus EC square, okay. So that's very simple. So we applied Pythagoras theorem to these 3 triangles and we got 3 equations. Now how to get this step out of these 3 equations? That's the question now. So I can add these 3 equations, okay. We can add because we have OA square plus OB square plus OC square. So I get that step by adding OA square, OB square plus OC square. So let's add all these 3 equations. So by adding I get left hand side, on the left hand side I get OA plus OB plus OC, okay, and on the right hand side I get these steps, okay, these steps comes on the right hand side. You can clearly have a look here, okay. Now still I did not reach the RTP required to prove. I'll convert it now. What's on the left hand sides? Along with OA, OB and OC we have OD, OE and OF. So these OD, OE and OF, I'll transpose them to the left, okay. So this becomes OA square plus OB square plus OC square minus OD square minus OE square minus OF square. So what remains on the right now? What remains on the right hand side? Remains only AF, okay, BD and CE whole square. So this is the way we can prove this easily, okay. There is another bit in this question which we have to prove, so let's go for that. Now in this figure, in the same figure, from the same figure we have to prove that AF square plus BD square plus CE square, okay, AF square plus BD square plus CE square, again you see it's alternate, is equals to AE square plus is equals to AE square plus CD square plus BF square, okay. Let's see how to prove this now. This can also be proved very easily, okay. Here as all the parts are coming in this, you can see all the parts are coming, AF, BD, CE and AE, CD and BF, all the parts are coming in RTP. So I need to take all the triangles. So I'll apply Pythagoras theorem again here for all the triangles. So let's apply it one by one. First we can begin with any triangle, that's not a matter. So let's begin with triangle ODB. In triangle ODB I can write OB square is equals to OD square plus BD square, okay. Then proceed with the next triangle OFB, then triangle OFA, then OEA, then OEC, then last is ODC. So I got all the 6 equations by using Pythagoras theorem from all the 6 triangles. Now here I can't add all the 6 equations, okay. Excuse me, we cannot add all the 6 equations because we'll not get our RTP by adding all of them. What to do? We can proceed in another way here. I'll take LHS first, okay. I'll take LHS and RHS separately and try to prove this. So let's take LHS, that is LHS is AF square plus BD square plus CE square, it's taken here. Now in place of AF square I can write from equation 3, you can see AF square can be written as OA square minus OF square, okay. OA square minus OF square. And BD square, where do we have BD? We have BD in the first equation. BD square is OB square minus OD square, okay. You can see BD is written as OB square minus OD square. The last is CE. What is last? CE. So what is, where is CE here? CE is in the 5th equation. So CE square is equals to OE square minus OC square, okay. So by transposing we get the different values for AF, BD and CE. This is LHS, okay. Then we'll simplify this LHS further and see what we will get. OA square minus OF square, same thing is taken here. Then OA plus OB square, OA square plus OB square plus OC square minus OF square minus OD square minus OE square. All the steps are taken here, okay. Just I opened the brackets, that's all. Same thing we should do for the RHS also, okay. What is the RHS? AE square plus CD square plus BF square. Then we'll proceed in the same way. I'll convert AE with, replace AE with You can see the fourth equation, AE is OA square minus OE square. Okay, then proceed in the same manner like we did for LHS. So we get these things in the right hand sides. Now when you simplify and check it, finally you'll find that the LHS and RHS are equal. There is no difference between LHS and RHS. So we can say that LHS is equal to RHS, hence it is proved. That's very simple. Okay, so the problem looks complicated, but it's very easy to simplify or solve it. Okay, so nothing is difficult if you try. Practice this before you forget it. Okay, let's go for the next question. Now here is an application question, application of Pythagoras theorem. So we have a ladder 10 meter long, reaches the window 8 meter above the ground. So you can see a ladder placed slanting to the wall 8 meter above the ground. It is reaching a window 8 meter above the ground. We have to find the distance of the foot of the ladder. We have to find distance of foot of the ladder from the base of the wall. Okay, so this is the foot of the ladder and this is the base of the wall. So we need to find this distance. What is the distance? So we can use Pythagoras theorem here and find it very easily. As we know that the wall is always perpendicular to the ground, so ACB is 90 degrees. Okay, this is ACB is 90 degrees. So ACB is a right angle triangle. We can use Pythagoras theorem here, that is AB square is equals to AC square plus BC square. Okay, that is hypotenuse square is equals to height square plus base square. Okay, we don't know the base here, so we need to find the length of this BC. 10 square, so let's substitute the values. This is AB is 10 and AC is 8. Substituting the values, we get 10 square is equals to 8 square plus BC square. 10 square is 100 and 8 square is 64. Transposing this to the left, we get 100 minus 64, and that is equals to 36. So BC square is equals to 36. BC is equals to root of 36. So root of 36 is nothing but 6 meters. So the distance from the base of the wall to the foot of the ladder is 6 meters. So by using Pythagoras theorem, we can find any missing side of a right angle triangle. There is another question which is given, that is 10th question. Here also we use the same concept. We'll use Pythagoras theorem and find the missing side. Okay, whatever may be the question, whatever may be the situation, we can find any missing side by using Pythagoras theorem. So try this question. I have simplified it for your convenience. Try on your own. If you get any doubt, you can have a look here. Okay, so complete this work and